Today we're going over how to track gas lift valves using the Gotek I-Plunger and surface gauges. A little bit of background on this data set is it was acquired via Slickline. This client is working on converting all of their gas lift wells over to GAPL, and they called us to help determine which valve is their injection point. Now what we can see here on the plot is that we have our I-Plunger pressure in blue, our surface tubing pressure in green, and our casing pressure in purple, and then this red line is the temperature of the I-Plunger as it's run down hole. Now the first thing I want to do is go ahead and get our velocity, and I'm going to do that by going to action and count ranges, and it will auto-populate and count our collars for us. I'm going to slide over for our rise parameter, and then I'm going to slide over the fall parameter as well. Next, I'm going to zoom in so that we can clean up our collar data a little bit, make sure that our parameters are right. I'm going to slide the rise range over as well as the fall. So I'm going to go ahead and double click anywhere on the plot to zoom back out, and what I can see right away are our gas lift valves, which show up in the purple curve here, which is velocity, and that's because the I-Plunger calculates velocity based on distance between collars, and the mandrels shorten that distance, so they show up as velocity spikes. Next, I'm going to go ahead and turn off our position to clean up the plot a little bit, and then I'm going to zoom in on our fall. This client thought that they were open at their third valve, but we were able to determine that they're open at their seventh. And I'm going to show you how we were able to find that. So first thing we want to go ahead and do is blow up our pressure curve and shut off our CCL data. Now I'm going to slide over the parameter so I can add a slope line on our pressure curve. I'm going to bring it down here. I'm going to go ahead and drag our range parameter back over. And what I can see here is we have a gaseous pocket that the plunger's fallen through, which is why it's so noisy. Then we hit a little bit denser column, maybe a little bit of fluid, but really at that seventh, we see a gradient change. And that tells me significant fluid and injection is entering the wellbore through that seventh valve. And by correlating with the latest tubing schematic, we could determine what pressure this valve is supposed to open at, and therefore find that it was the seventh valve they were stuck open. Now what I'm going to do is slide over the parameter again, and we're going to see what our depth is in order to put our plunger stop at. And we want to hang it just a little bit above that valve so that we get injection to help lift our fluid and plunger. Now, using the I-Plunger, we are able to help this company determine that they were open at their seventh and not their third valve. And what this did was not tear up any new plunger lift gear that was installed, as well as lower their bottom hole pressure more effectively. Please don't hesitate to reach out to us for a free consultation and let us know how we can help you today.